full screen mode. Okay, thank you very much, Jörn, for the introduction. Yeah, it's my pleasure to give you a bit of an overview of what I consider prospects for polar prediction. When I talk about prediction, what I mean in the following are forecasts on time scales from daily to seasonal. And I will make this presentation in the context of two major projects that are actually related, as we'll find out in a minute: the Polar Prediction Project and its flagship activity, the Year of Polar Prediction. That it's activities that I coordinate as chair of the steering group of the Polar Prediction Project. And let me start with say a few words about those projects. And I think the story is best told by explaining how it came about. And you see here a very well-known figure. That's how September Arctic ice extent developed over the last few decades. And what is interesting, if you look at this in detail, is that you had a relatively slow decline until the turn of the 20th century. And then, the decline was quite rapid thereafter. And you could argue actually for this, this time window, from the late 1970s to the early 2000s, that, polar prediction wasn't really an issue for people. It was partly due to the fact that there was little stakeholder activity. Traditional knowledge on weather and climate worked tremendously well, for people out there. And, there was also hardly any interest in this discussion of, linkages. Now, this changed in the early 2000s, with climate change, obviously, when there was increasing stakeholder activity. You may argue that in a rapidly changing climate, traditional knowledge may be challenged. And, all this was accompanied by a great interest in linkages. Now, there's also another dimension to that story, and that in the early 2000s, IPY came to an end, and the World Weather Research Program discussed about its future, and that's really when the topic of polar prediction moved into the focus. And WMO launched as part of its World Weather Research Program, the Polar Prediction Project. And the idea is, I don't want to read the details, but it's really going beyond weather to environmental predictions. So, considering the coupled system, which is tremendously important in the Arctic, even on short timescales, and going from hourly or to seasonal. Now, in our kickoff meeting in 2011, we recognized that we need a focus, so what we called then a year of polar prediction. I think it was actually Ian Renfrew, who will be presenting later, who came up with that idea of calling it a year of polar prediction. And again, I don't want to read the mission statement, but it's about improving environmental prediction capabilities, coupled system again, moving the polar regions in the focus, because the focus has been in previous international attempts on lower latitudes, and also considering linkages. And this year of polar prediction came in three phases: preparation phase, core phase, and we happen to be now in the consolidation phase, and having a bit more than 1.5 years still ahead of us. Now, I would like to spend a bit of time in giving you an idea of some opportunities that arise from activities during the YOP core phase. And one is certainly related to special observing periods. So attempt that we made to close the gap that is there in the Arctic observing system as much as possible during certain periods of time. And we had one special observing period, for 2 months in winter 2018, where we had almost 2,000 extra radiosondes from 16 different sites, scattered around the Arctic, involving 7 different nations. But where we also had a very strong buoy program, also with contributions here pictured, from Russia. Again, trying as much to fill the gap that is there. Now, I don't want to talk too much about the impact of observations. I think Irina will be giving you a very, very nice overview of where we are and what's our understanding is of that. I just would like to point out that adding observations and maintaining this is certainly an important task. But what we learned really during the last few years is that taking observations in specific periods, so carrying out so-called targeted observations, might actually be another powerful way of making efficient use of observations, and that holds for generating process understanding, but also for improving predictions. And we were looking during the Mosaic period. We were looking for these interesting weather events, and as many of you know, we were locked in a sort of very specific weather pattern, especially during winter, during most of the Mosaic campaign. But then in April, some undulation of the jet stream occurred, and you see here the jet stream, for the 19th of April 2020, where you see that it's going all the way to the Arctic and then recurving and going back. And these kind of undulations of the jet streams go along with intrusions of warm and moist air from the mid-latitudes towards the Arctic. And there's lots of physics, going on, and it's a challenge simulating this. And, there are forecast errors growing along the line. So that's certainly something that attracts our attention. And, this, I guess, will be a sort of a unique case that will, keep scientific journals busy for years to come. So we launched extra radiosondes and extra observations that, again, I hope will be picked up by the community. But I think this idea of this meandering jet stream and, these, linkages, periods of strong interaction between mid-latitudes and the Arctic and vice versa, Arctic and mid-latitudes, I think that is also something that emerged as a hot topic in recent years. And usually, this is a typical picture we are interested in. It's interesting and hot, the impact of Arctic sea ice decline on lower latitudes. But you can also ask and consider linkages from a prediction perspective. You can ask, for example, the question, if we would have more observations and better in the Arctic, would that lead to enhanced prediction skill in lower latitudes and vice versa? And I think there were a number of recent studies, and I just selected a few here, and which give rise to an interesting picture that is emerging. And that's pictured here sort of in a climatological sense. So you see the Northern Hemisphere, you see something like the climatological jet stream here, this white band. And what we find is that, quite often, weather forecasts, or, skill or errors basically in the North Atlantic, now they enter into the Arctic through this corridor just east of Greenland, associated with these intrusions we've just seen. And what we also noticed is that there are two main corridors, where forecast failures in the Arctic, or possibly enhanced skill might impact primarily lower latitudes. And that's a corridor here over Eurasia and a corridor over North America, and that can be explained by and large, the structure of the climatological jet. Now, more recently, we also noticed that this is a climatological picture on the right-hand side, but there's a very strong flow dependence. On some days this link is particularly strong, and then these linkages really matter, whereas on other days that might not be so much of a concern. And particularly interesting in that context is the paper by Johnny Day, who worked out that, Scandinavian blocking events, when they are prominent or present, that basically what you see is that air from mid-latitudes is entering the Arctic, and then, returning back towards the mid-latitudes and impacting skill then there. And, there are major challenges that you have to simulate here. I mean, sort of major processes like, interaction with topography playing a role here, interaction at the air-sea interface, I think Ian will be talking about this, but also air mass transformation. And, you have jet streams. If errors develop here, they will propagate with the speed of, the group velocity of Rossby waves, into the Arctic and out again. Regarding, speaking of opportunities, we also provided to the community activities that are going on, meetings coming up and so forth. And with this, I leave it here and stop.